Welcome students for the econometric methods course. In the last few sessions, we learned to estimate, report and interpret Cobb-Douglas production function. In this module, we are continuing that discussion. We shall estimate a Cobb-Douglas production function using the given sum of square measures. In the end of the session, you would have learned to handle a special model and its interpretation. Let us have the example for estimating the Cobb-Douglas production function. In the previous problem, we estimated the Cobb-Douglas production function by using the production schedule, that is, we have given the schedule for 14 years separately for output, capital and labor. But today in this example, we have estimate the Cobb-Douglas production function y equal to beta naught L power beta 1 into k power beta 2 using the following intermediate results. That is, here in this problem we are given only the intermediate results, that is all the some values are given here, like the summation of y, that is the output, the summation of output level, and the summation of x1, here x1 is considered as labor, and the summation of x2, x2 is considered as capital, and the summation of small y square, that is this is the deviation taken from the average value of y from the original value of y. Similarly, we have the summation of small x1 squared, small x2 squared, the summation of y x1, the summation of y x2, the summation of x1 x2, and these results are obtained for the 15 observations. So, in this problem we have to estimate the Cobb-Douglas production function for the given intermediate results. So, in order to estimate the Cobb-Douglas production function, we need the average values of the output, capital and labor, that is output is considered as y, labor is considered as x1, capital is considered as x2. So, the y bar can be calculated by taking the ratio between the summation of y and the number of observation. So, which is equal to, we have the summation of y as 56.197 and the number of observation is 15. Therefore, 56.196 divided by 15 will give 3.746 and x1 bar is equal to sigma x1 divided by n, which is equal to 29.839 divided by 15. So, x1 bar is equal to 1.989 and x2 bar can be calculated by taking the ratio of sigma x squared and n. So, we will get x2 bar as 4.998. After getting the average values, we may calculate the coefficients, regression coefficients beta naught, beta 1 and beta 2. So, in order to find out the regression coefficients of beta 1, we may have the formula that we have already studied. So, beta 1 hat is equal to sigma y x1 into sigma x2 squared minus sigma y x2 into sigma x1 x2 the whole divided by sigma x1 squared into sigma x2 squared minus sigma x1 x2 the whole squared. So, here we have to substitute the values for all these terms. So, which is equal to sigma y x1 is equal to 0.898583 and sigma x2 squared is 0.464055 minus 0.887711 into 0.471915 the whole divided by 0.485894 into 0.4640 0.55 minus 0.471915 to the whole square. So, this will give us beta 1 hat as minus 0.695. Beta 2 hat can be calculated by using the formula sigma y x 2 into sigma x 2 squared minus sigma y x 1 into sigma x 1 x 2 the whole divided by sigma x 1 squared into sigma x 2 squared minus sigma x 1 x 2 the whole squared. So, here also you have to substitute the values for these things. So, by substituting all the values in this formula, we may get beta 2 head as 2.620. After getting the values of beta 1 head and beta 2 head, we may calculate beta naught head, which is equal to y bar minus beta 1 head x 1 bar minus beta 2 head x 2 bar. We have already calculated y bar, x 1 bar, x 2 bar and also beta 1 head and beta 2 head. By substituting all these value in this equation, we may get beta naught head as minus 7.966. Then we may calculate r square. As we know, r square can be calculated by using the formula beta 1 head into sigma y x 1 plus beta 2 head sigma y x 2 divided by sigma y squared, which is equal to, and we know beta 1 head is minus 0.695. We have to substitute this value in this equation, so that we could get minus 0.695 into 0.898583 plus 2.620 into 0.887711, the whole divided by 1.724934, which is sigma y squared. So, after substituting all the values, we may get r squared as 0.986143. Now, we may calculate the sigma squared head, which can be calculated by using the formula the summation of E squared divided by n minus k. Here n is the number of observation, that is 15. So, the n is equal to 15 and k is number of variables. So, here we have 3 variables. So, n minus k is equal to 15 minus 3, which is equal to 12. So, here the summation of E squared may be calculated by using the value of r squared and sigma y squared as 1 minus r squared into summation of y squared, which is equal to 1 minus 0.986 into 1.725, which is equal to 0.025. After substituting this summation of E squared in the formula of sigma squared head, we may get sigma squared head as 0.002. Now, with the value of the sigma squared head, we may calculate variance of beta naught head. For calculating the variance of beta naught head, we have the formula 1 by n plus x 1 bar squared into sigma x 2 squared plus x 2 bar squared into sigma x 1 squared minus 2 into x 1 bar x 2 bar into sigma x 1 x 2 the whole divided by sigma x 1 squared into sigma x 2 squared minus sigma x 1 x 2 the whole squared, and this entire thing should be multiplied with sigma squared head. After substituting the values for x 1 bar squared, sigma x 2 squared, x 2 bar squared, sigma x 1 squared, sigma x 1 x 2 in this formula, we may get the value as 2.963, that is sigma squared head is 2.963. Now, we may calculate variance of beta 1 head with the formula of sigma x2 square divided by sigma x1 square into sigma x2 square minus sigma x1 x2 the whole square into sigma square head, which gives 0.33271. After getting this value, we may go for calculate. We have calculated variance of beta naught head as 2.963. Now, we shall calculate variance of beta 1 head using the formula sigma x2 square divided by sigma x1 squared into sigma x2 squared minus sigma x1 x2 the whole square into sigma squared head. After substituting the values for sigma x2 squared, sigma x1 squared, sigma x1 x2 and sigma squared head, we may get variance of beta 1 head as 0.33271, and variance of beta 2 head can be calculated by using the formula sigma x1 squared divided by sigma x1 squared into sigma x2 squared minus sigma x1 x2 the whole squared into sigma squared head. After substituting the values, we may get variance of beta 2 head as 0.34837. Now, with the values of variance of beta naught head, variance of beta 1 head and variance of beta 2 head, we may calculate the standard errors of the regression coefficients. Now, the standard error of beta naught head can be calculated by taking the square root of variance of beta naught head. We have calculated variance of beta naught head as 2.963. By taking the square root of this, we may get standard error of beta naught head as 1.721, and the standard error of beta 1 head can be calculated by taking the square root of variance of beta 1 head, that is the square root of 0.33271, which gives 0.577 as standard error of beta 1 head, and the standard error of beta 2 head can be calculated by taking the square root of variance of beta 2 head. Here the variance of beta 2 head is 0.34837. Now, by taking the square root of this, we may get standard error of beta 2 head as 0.590. Now, with the value of r squared, we may calculate r bar squared. The r bar squared can be calculated by using the formula 1 minus r squared into n minus 1 by n minus k. Here r squared is 0.986. After taking the difference between 1 and the r squared, we have to subtract this from 1 and then multiply it with the n minus 1 by n minus k. By substituting and multiplying this value, we may get r bar squared as 0.846. Now, the f value can be calculated by n minus k into r square divided by k minus 1 into 1 minus r square, which is equal to n minus k is nothing but 15 minus 3 and r squared we have already found out, that is 0.986 divided by k is 3, therefore 3 minus 1 into 1 minus r squared, which give 422.571. So, we have calculated the regression coefficients of beta naught head, beta 1 head, beta 2 head, standard errors of beta 1 head, beta 2 head and beta naught head. With all the calculated value, we may report the estimates of Cobb-Douglas production function as y hat is equal to minus 7.966. This is nothing but the beta hat value, minus 0.695, that is beta 1 head into x1 plus 2 plus 620, this is beta 2 head into x2, and the standard errors of beta naught head, beta 1 head and beta 2 head are also to be reported here. and the t values are also given here. So, with the estimates of Cobb-Douglas production function, we may give some interpretation. The critical values, it is very important that we have to take the critical values. So, the f value can be taken with the degrees of freedom 2, 12 is equal to 3.89 at 5% level of significance, and the t value is also taken as t at 12 degrees of freedom at 5% of significance is 2.1788. So, interpretation with the all estimated values of the regression coefficients beta naught head, beta 1 head, beta 2 head, the standard errors of the regression coefficients and the values of t, we can interpret the model. The model is significant as far as concern the value of f. Since the calculated value of f at 2, 12 degrees of freedom is greater than 3.89 at 5% level of significance. That is, the calculated value of f is 422.571, which is greater than 3.89. So, we may conclude that the model is significant at 5% level of significant. Regarding the r squared value, it is 0.986. So, we may say that 98% of variation in y is explained in the model. The regression coefficient beta 1 is insignificant because the calculated value of beta 1 head is less than the 2.1788, that is the table value of t at 12 degrees of freedom at 5% level of significance, and the regression coefficient beta 2 head is significant at 5% level, that is the calculated value of beta 2 head is 4.439, which is greater than the table value of t at 12 degrees of freedom is 2.1788 at 5% level. So, we may say that beta 1 is insignificant and beta 2 head is significant at 5% level, and we come to the elasticity of output with respect to the inputs, that is capital and labor. The elasticity of output with respect to labor is minus 0.695, which indicates that 1% increase in labor leads to an average 0.7% decrease in output, keeping capital constant. Here why we are saying that when labor increases with 1% level, the output decrease about 0.7% is that here the beta 1 head is negative. Therefore, increase in labor may leads to decrease in output. Regarding the elasticity of output with respect to capital, which is 2.620, which indicates that 1% increase in capital leads to about 3% increase in output. By adding these two elasticities, beta 1 head plus beta 2 head, we may get 1.925. These elasticities, these sum will give us 1.925, which is greater than 1, which indicates that the firm is operating under increasing returns to scale. Now, we have another problem, that is, suppose we estimate a Cobb-Douglas production function and obtain the following results for the function y is equal to beta naught L power beta 1 into k power beta 2. Here we have given all the estimated results, that is given in a reporting form. In the previous example, we have given only the intermediate results. With the intermediate results, we found all the regression coefficients, variance, standard error, R squared and everything. But in this problem, we have given all the regression coefficients, standard error and the calculated value of t, everything. With the result, we have to interpret beta 1 and beta 2. So, here the question is, how do you interpret beta 1 and beta 2 with this form? Interpretation. Now, we are going to interpret the estimated results of Cobb-Douglas production function. The model is significant at 5% level, since the calculated value of f with 2,12 degrees of freedom is greater than the table value of f with 2,12 degrees of freedom, that is 3.89. So, we could say the model is significant. Regarding the R squared value, we may say that 98% of variation in y is explained in the model. Regarding the regression coefficients, the regression coefficient beta 1 is insignificant, because the calculated value of beta 1 head is less than the table value of t at 12 degrees of freedom, that is 2.1788, and beta 2 head is significant, because the calculated value of beta 2 head is greater than the table value of t at 5% level. The elasticity of output with respect to capital is 2.620, which indicates that 1% increase in capital leads to an average 3% increase in output. But since beta 1 head is insignificant, therefore, the returns to scale parameter cannot be obtained. So, the inference regarding that could be obtained only after further statistical test, which is beyond the scope of the discussion of this course. Conclusion. As promised, the model discussed today does have a special problem, in which one regression coefficient was not significant. In this context, be mindful about the statistical significance of the parameter estimate. With this, I conclude a discussion about production analysis using Cobb-Douglas production function. I am looking forward to interactive session. Thank you for your patience listening. Until we meet, goodbye.